Okay. Hello. Do. Hello. Hey, Crypto Code, Minister of Defense. Hello, everybody. Okay. What is the state of things? I don't know. Actually, I do know. So yesterday, I thought I was winning, but I wasn't. I actually had a bug that prevented Dread from actually kicking in, and so we were not using it. But here's what I discovered in the meantime. I discovered also that so this Opus has a thing called DTX, where basically it's discontinuous transmission. So if there's silence, you don't send packets. Now, here's the thing. I was making my own version of DTX, where if the voice level of a packet worth of samples was, let's call it a frame. They keep calling these things a frame, although in other contexts, a frame is all the samples corresponding to different channels. Just one sample, all channels. But let's use their terminology. If a frame of packets of samples had a power that was too low, below a threshold, I would just not send it, regardless of what Opus said. Now here's the problem. Here is the problem. The problem is that basically it turns out that doing that, it turns out that the Opus doesn't really like when you drop its packets that way. Or rather, normal Opus is fine with it because we were using it that way and there was absolutely no issue whatsoever. But it turns I went through all the issues on the Opus GitHub to see all discussion related to this stuff, and at some point they pointed out that with DTX on, Opus sends a packet every 400 milliseconds to update the decoder. And so it turns out that I basically, after I fixed the bug that prevented Dread from kicking in, I kept having the same problems again, with like weird artifacts at the end. And so I said, okay, you know what? I'm gonna try to enable DTX and just never kill packets myself. I'll follow everything that they say, start to finish. And it turns out that if you do this, if you enable DTX and you don't drop Opus packets that you're not supposed to drop, it works. So let me, I guess we're saying goodbye to the music real fast today. Oh, I was also streaming music on YouTube. Oh, delightful. Yeah, thank you. Yeah. You're right. Okay. Well, mistake fixed. Hopefully YouTube doesn't kill us. Test. So let me bring up the packet loss thing. Also, sorry. I'm gonna leave because I broke the mute button. To make the DTX stuff work, I had to break the mute button. So you will see that also there's like a bunch of restarts happening even when I'm not saying anything, and that is because in DTX mode, Opus sends one packet. Like in most packets will be empty, so you don't have to send them. But every 400 milliseconds during silence, it will send a packet with some stuff, and not sound, but with information to update internal state of the decoder. So that's why you see those restarts happening when I'm not speaking. It's this single packet that goes out on its own. So test. More volume. Test. I'm gonna drop packets. Test. So you see the weird stuff goes away. Banana. Banana. 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 3. Now it's fine. So I still don't think it's okay. I still don't think this setup is 100% correct, because there's a bunch of shitty artifacts when I drop 3 packets. And there's a bunch of shitty artifacts. I don't know. I just don't like it. So, I just do not like it. And but you notice that now it doesn't corrupt afterwards the voice, or rather it is corrupted for a brief moment, but then as it starts receiving stuff again, it unfucks itself essentially. So I do think that the DTX stuff has to be used this way no matter what. That means that we need to implement the microphone stuff differently, because previously we were just in a network thread, we were just observing the state of those samples, And well, now where is it? Wrong file. We are just observing if they were above or below the threshold, and then if silence, we were just short circuiting. But now it's different. Now it's a little bit different. So what does this mean? This means that we need to implement muting at the audio interface level, and we need to implement the threshold also in a sense like that. So how do we do this? You know what? I think I'm gonna put the music back. Is YouTube okay? Why does it keep fucking up? Okay, YouTube is fine. Maybe. Okay. Put the music back, put the music back, put the music back. Okay, so what we're gonna do is we are going to go to audio and introduce the concept of muting and unmuting the microphone. So let's see. The init, ensure capture permission. Is there a already muted thing? No. I don't have capture muted. Interesting. Now, here's the thing. And now that I think about it, though, server side muting will have to, it will have to work by dropping packets from a client. How is that going to work with this? Hmm. Also, mute status needs to be. So I have it in call, I think. If I look in core, or I thought I did. No, it's in Awebo. Call layers have this state. Known, muted, server muted, deafened, server deafened. Wait, can you server deafen somebody in Discord? Holy shit, yes. Okay. So how should server deafening interact with the client? Should the client be made aware? Um, yes, the client needs to be made aware. Actually, server deafening is kind of a tricky feature because, or even server muting, because server muting could be a lie in the sense that server says to everybody else that a given client is muted. It stops sending audio streams to other clients, but then it records those streams. Server muting is a problematic feature if you don't trust the server admin. Discord still sends them, just doesn't play back on client side? Really? You're saying that not only the client that is server muted keeps sending data to the server, but the server keeps sending that data also to other clients, and then other clients just don't play that sound? That's how it works? As someone who has been using Zig now for about a week, I still find myself struggling to navigate and understanding the standard library. How would you recommend me try to go about understanding it? Um, there are two main things to keep in mind. Your standard library lives in this directory. I mean, it depends where you installed Zig, but somewhere you will have an installation of Zig and it will have a lib directory in it. In here, there's a bunch of C lib implementations. You don't want to look into those. Those are bad. What you want to look into is std. So you enter std. This is the Zig standard library. Your entry point is zig.zig. No, sorry, I'm wrong. Your entry point is std.zig. Where is it? There you go. This is your entry point. When you do add import std, when you add import std, this is the file that you're importing. And so when you do go to definition, that's where it brings you. In my case, it brings me to a different path because this is a different installation of Zig that I'm using rather than the source code in that directory. So your std.zig contains the root of your definitions, and then you can take a scroll and see how things are organized. You will see that some definitions are plucked out of certain namespaces for your convenience, so that you can access them more directly, while some other ones are just divided into sub namespaces, and that's just where you have to navigate into them if you want to get definitions from them. Then, what else? I don't know. It depends on what you're looking for, right? Some things will be easier to understand than others. So, for example, you want to see how atomic works. So there's an atomic value. An atomic value is designed to work like this. This is an example of making a ref counted thing, but in general, you create an atomic value, and then your value is going to be wrapped in a struct that guarantees. Oh, these guys are extern struct. I didn't know this was an extern struct. Good choice. So this guarantees that access to this value is done through atomic operations. You don't have to do this because you can use the built-in atomic operations on normal values if you want, but by wrapping them in a type, you kind of make this more type safe. So in here, you can read the whole implementation. Like, this is how the whole implementation works. And yeah, that's how you do it. Same for the other namespaces. Then if you're looking for certain things, Like if you have a specific use case in mind and you wonder if the standard library has something for you to help with that or not, um, I don't know. Try asking, and I'll try to give you my answer. But these are the basics essentially on how you use the how you browse the Zig standard library source code. Use go to definition. Every time you use something, go to definition on it. Like make sure that your editor is set up to be able to go to definition. And then every time you see, oh, there's an IO or there's an auto array hash match manage, blah, blah, blah. Okay, go to definition. Oh, this calls this guy. Okay, go to definition. Oh, look, there's comments. And I can see what it keeps inside and which functions it exposes. Also, another trick is to search for um, pub fn to see public functions. So basically the function interface. That helps. Also, sometimes pub const is useful. Const gives you type definitions. Pub function gives you functions, obviously. Let's see, I probably confused it. I still get voice activity of other users when I deafen myself. But it could be just that voice activity is sent separately. Well, you see the voice activity of other users. Yeah, but that means... Oh, you know what? Then maybe that is a good point. When you deafen yourself, you see voice activity of other users. I think that means that is a very good point. That means I think that so as far as I'm aware, I believe that Discord. So I heard that Discord sends voice activity over TCP. It doesn't use UDP data for telling you about that voice activity. Now, that being said, it could be that you just receive all the data and then the client just doesn't play it back. Yeah. For example, a CD process init in the standard library docs. I think I understand that fields are parts of the struct, but that's where my understanding ends. I'm not sure what minimal is and such. Well, why are you looking at the docs? Don't look at the docs. SCD process.init. Go to definition. So init is a struct, as minimal as a field, arena as a field, GPA, IO, environment map, preopens. Like your knowledge of Zig can be used, of Zig syntax can be used to understand what these things are. So what's minimal? Minimal is a nested, it's a namespace type definition. So now you know. And you have docs for all these things. So now you know which is which. So you know that an init contains a minimal, and then a minimal contains something that represents environment variables, something that represents command line arguments. You can go to definition and see what args is. Args is defined in a different file. So args contains a vector. Holy shit. Blah, blah, blah. Has to be created to allocate runtime. Windows. For Windows, a vector is a slice of UX16. Blah. In WASI, if you don't link libc, it's nothing. For everybody else, it's a slice of null terminated strings. And then you have an iterator. And then you can go back and say, okay, so this is what args is. And then environ, what is environ? Again, a different file. Environ has a block in it, unmodified, unprocessed data provided by the operating system. Okay. And then it has a map type. And then you have a function called create map. Allocates a map and copies environment block into it. So basically, you can create a hash map to access your environment variables, but it's not done by default. You have to request it because obviously it uses resources, and that's what minimal is. Then if you then means that if your main function asks for a STD process init minimal, then that's all you get. If you ask for all a more full init, then you get this, which also includes a built environment map. So yeah, there you go. And once you understand this, then you can go to the docs if you find that more convenient and understand. And now you know that fields are struct fields, and you know that other things like minimal and such are nested declarations. And that way you can decode whatever the docs don't explain well, because you can leverage your knowledge of the language. And your knowledge of the language, it's the actual ground truth. So from there you can build more understanding. Okay, so I was looking at this guy. So we were talking about the semantics of getting server muted, server deafened. Yeah, it's tricky. It is really tricky. Although, so for the server to steal your sound, it still has to not tell you that you're muted, though. So here's what we want. We want to make sure that if we are in any of these states, we want to make sure that these is synced to our we want to make sure that this is synchronized to our audio state. But we still cannot trust the server. There is one thing that for sure we don't want to happen. So if we are not muted and then we go into server muted, then yes, we want to mute our microphone. But if we are muted and the server sends us into server muted, once server muted is removed, we don't want the server to be able to unmute us. That is absolutely important. So turns out that this status is actually wrong, because we need to keep track of these things as separate booleans, because you could be muted and server muted, and then when we remove the server muted, you should still be muted. Or you could be just server muted, and when that gets removed, then you go back to normal. So this looks like something that could be an enum, but it is actually not. It is actually not. So now here's the question. Who should own this state? I don't know who should own this state. So some of this, you know what? This is fine to be owned by this guy. This type, this is fine. I think that this type is as it should be. But then we need somewhere else where to store these in these like separately as like separate flags. So I think this goes into audio. We could put it in the active call. Active call would also be a good place where to put it. Maybe. Did you just miss an explanation of enum versus tagged enum? You mean union versus tagged union? There are no tagged enums. Tagged union is a union that has an enum field that tells you which is the active case. enums are just enums. But no, I was talking about the difference between how to represent the relationship between you muting yourself versus the server muting you. And uh, so here's the idea. These days as is, audio gains this information. Tag unions are for switching on, right? Correct. Yes. So we have capture muted, we have playback muted. Now the question is, do we put in here also server muted or not? Hmm. Yeah. Yeah. um. No, I think that server muted should go in active call. Okay, I think I understand how this should be. This guy only tracks if the actual state of the audio interface, and then active call tracks what the transitions should be. Okay, there we go. So ensure capture permission, set devices. Let's put in here pub function set capture muted, unmuted. You know what? Actually, this could be better. This could be a device state. Muted, unmuted, um, broken. Let's do broken, muted, unmuted. Yeah. And then capture has a state. Oh, this is helping me model other stuff that we're not tackling yet, but so capture permission. So we have set capture, muted, unmuted. Caputure. Thank you. Audio. Okay, set state. He's muted. Audio capture state. Broken. Um, what if you try to mute a broken device? Let's do nothing. So I guess we can return returns if there was a state transition. If it's broken, no state transition. What I mean is, you are trying to prioritize a malicious server, not pawning a client more so that a rogue client doing weird things. Um, Generally speaking, a rogue client doing weird things results in the admin doing right click ban. So, like, if you go to a voice channel, like, you don't even need to modify your client, right? You go to a voice channel and you start yelling at people. I don't know, you can do that a few times. After a while, people are gonna get annoyed and are gonna right click ban you. So in general, the server has more power to contain misbehavior from clients. So it's not a big of a deal. Obviously, the client, there needs to be uh, sanitization of inputs so that the client isn't allowed to overwhelm the server. For example, we already have rate limiting in place. Like, if your client spams the server too much, you just get kicked. Sorry, you just get automatically disconnected and banned. Um, but if the server is, but the server is, how can I say, the server can be more sneaky in how it does bad stuff. Um, that's kind of the idea. I think this is nice. So we asked the OS layer to apply muting to capture state, and then we return if that, and then we expect this to be synchronous and to tell us how it went. Okay. So now we need to do the same again for unmuted. So if it's broken, do nothing. If it's muted, if it's unmuted, if it is muted, there we go. Okay. Okay. Returns if there was a state transition. Um, do we have a pointer to core in audio by any chance? No, we don't. Finally, we have it in color. We don't have it in audio. We'll keep it also in audio. Oh well. Okay. So okay, with this we have the initial concept of asking the OS to mute capture. So let's do this. Set devices, start call and blah blah blah, capture push, blah blah blah. macOS interface. Above here we do pub function set capture. Oh, we're about to do Objective C. I hope everybody's excited as I am. Oh, blurry cat. Uh, okay. So I vaguely remember there was a toggle for muting input. Um, macOS set input muted. There we go. Okay, it is an Objective C thing, and you do it on a VA audio application. So yes. Ah, delicious, delicious Objective C. Hmm. There we go. This is gonna be easy. This is gonna be so easy. Like it's literally a copy paste of this. I don't know why I thought that Awebo made sense in this case. That's not it. Awebo is the prefix for callbacks, which we don't have in here. No, come on. AV audio application. Oh, it's an instance method. Set input muted, and it can return an error. Interesting. It's an instance method, so we need to get we need to get the shared instance. Is this a method? No, it's a property. So we can do this, I think. We can do dot shared instance and then space, and here we can do hello Ethernet cable. Just very briefly. Um set input muted. Okay. Um okay, we need to think about the state. So 0 is broken, and we're not gonna be asked to ask that. So we are gonna need we're gonna do copy paste. I mean, it would be nice to make a variable. Problem is it's gonna suck. So we're copy pasting this instruction. So if state equals 0, built-in unreachable. Else if state is 1. Actually, you know what? We're gonna do it like this. There we go. If state equals 1, I believe this is muted. So set input muted true. If state equals 2, that's unmuted. That's false. We double check this. Yeah, muted is 1, unmuted is 2. We need the NS error stuff. Give me an NS error. Oh, come on. I was doing so many things with an S error thing somewhere. There we go. There you go. Does this also return a value? It returns Boolean. Okay. Does your neck hurt from looking to the right all day while programming? I look also a lot to the left. It's fine. No, wait. What does the thing return a boolean? But it didn't tell us what the return value means, right? What does the boolean mean? Wait, maybe these docs have. It doesn't tell you right below the method. I mean, in here. No, this is the this is the comment. This is the doc for input muted. This doesn't tell you what this return value from this guy means. It doesn't tell you if it was the previous state, if it was error or success. I think it normally is error or success. Although I don't remember how you do it. Like I don't remember if you do if. I think you do it like this. If no error, then let's make it return false. And then this is essentially also here. Like this. I think this is how you do it. Um, okay. Audio. What was it? What do we want to call the callback? So this is how we do the capture mute state. So if this errors out, the fuck do we do here? We kind of want to get the capture mute state and see what it is. Hmm. I'm also starting to think that broken should probably be a separate flag. Let's do device mute state. Let's remove broken. So let's put them as 0 and 1. Yeah, and then we deal with them being broken in a separate way. And then this is simple. If audio dot capture. Let's see. Good morning. I've been using Flow more lately, and it's better than I expected. Nice. It's going well. I usually can't get productive quick enough with terminal editors and struggle. Nice. Uh, Capture state is set capture muted. Capture state. So, okay, let's account for these potentially failing. I guess the way it works is that this doesn't return the state, it just returns if the request succeeded or not. So we can do it like this. If set capture, then audio capture mute state equals the new state. Return true. Otherwise, return false. Although, you know what? I think I prefer to talk it in terms of errors with these things. Failed. Oops, mute state. Hmm. I think this can also fail. So we don't catch. We try. There we go. Or even better. Oh man. This code simplified itself. It took me a while to do it, but look, this code simplified itself in the end. Set capture, errors are good. Errors are good. I should always use errors. Never get tempted to use fucking booleans because C uses booleans. Immediately turn booleans into errors as soon as you can. Don't get memed by C. So If capture state is the same, return false. There's no transition necessary. If state is different, then try to set it. Capture mute state gets assigned on success. We return true because there was a transition. Set capture returns error failed. Calls into our thing with this state. If this returns if this returns an error, return this. Audio M. Audio M. So these are going to be now 0 and 1. If there is an error, we print the error and we return false. Returns true on success. Okay. Okay, so we have set capture now. So this side should be implemented. The next problem is we need to wire the actual button to this behavior. So let's go into channel list. Here we have a muted button, I think. Yeah, mute on mute. Call.muted. So how does this work? Core call mute toggle. So this is more complicated. This is more like I think it should be like this. The button should be mute and unmute, and it should control our local mute and unmute. And then it should be red if we are server muted or server deafened. Okay. I think I have a plan. I need a quick bathroom break and then I'll continue. Also get some more tea. I'm back. Do. Okay, let's do some magic. So, also, here's one other realization. If we are muting ourselves, we cannot just ask the UI. We need to ask the call, and the call needs to ask the uh, audio because we do want to communicate to the server that we're muted. I mean, right now we don't have support for this, but that's a thing they want to implement. So do we cache this information in the call then? Yes. Muted. We want to keep this information in here. Call mute toggle. Oh, really? That's all we do? That's bad. No, let's not use booleans. Let's use core.audio. We are in core, so we can do audio dot device mute state. It's not pub. You can make it pub. Actually, this guy should go below. Then in here, okay, so here we can do return call muted not. The difference between this and what we were doing before is that here we guarantee that the user is asking to perform the operation that they see in the GUI. The previous semantics with toggle, it's not exactly guaranteed. Let me think about it for a second. What if they click spam it? Like if they click spam it, I mean it's gonna do the right thing, I guess. Whatever. I just like I like this way of doing it more. So with this, we do set muted to new state, and then we do AC. Now we do core.audio dot capture mute state. No, we don't set it. We do set capture to new state. Now, what if this fails? Huh. Well, we actually do this first. And we do log.debug, enable to toggle capture mute state. I don't know, we don't do anything, and then we just return. So we don't perform the state transition if we actually cannot perform the state transition. This can fail, right? Yeah. Oh, and there's also a boolean that is returned. If transition core.refresh. Yeah. Okay. This is actually good. This is actually good. So now Cole knows what the target state is. Okay, I don't know. Does this work now? I can try it. If we can get to a compiling state, there's also that. So now, yeah, now what is network gonna do? Now network had some stuff about this, but yeah, we can all comment it out. Hopefully there's not any more of that. What? Specific arguments found too. Okay. Unused local constant active call where in network. Okay. Really? That surprises me that it was not used anywhere else. That truly surprises me. Um, Core refresh expects 3 arguments. Yeah. Wait, you have to do it like this? Really, man? That sucks. Okay. Test. Test. Muted. You didn't do shit. Muting did not do shit. Muted. Muted. Unmuted. Excuse me? It is another giant Apple moment. Ah, 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 ah. Why is there not a single fucking thing that works? Just one, please. Just get one working. Why? Why? Test, 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 test. Why is Apple like this? Test, 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 test. Okay, so here's how we do it. Here's how we do it. Move this down. Accept a manager. Do this bullshit, maybe. I don't know. Um, but before doing this bullshit, we do what actually works, which is this manager.engine.input node.volume equals 0. There we go. So now in audio, You haven't seen opaque before? It's a very nice way um, of of dealing with SIM interoperability. What does it mean? Have you ever used C? Test, 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 test. Okay. Test. Muted. Muted. Yes, we are muted. Okay. This still shows up though. This is wrong now. Unmuted. There we go. Okay. So, okay, if you use C, opaque is basically a way of having um, a C void star, a C void pointer, but you can give it namespace functions in Zig. So when you have a void pointer from C, usually you cannot distinguish between different void pointers at the type level, right? Because you could have, for example, a thing that allocates a type of resource that you don't know the exact specifics of the type, but then you get a pointer. And then you have pointer erasure where that pointer sometimes gets turned also into a void pointer. In Zig, if you didn't have opaque, every time you have one of these things, so in my case, I have this Objective C code that creates this resource, a um, audio engine manager. This is a Objective C object, I think. So we talk to it. So we refer to it via a pointer, and so there is no equivalent type for Zig. So if we didn't have opaque, we would have to. So to create this thing, we call this C function audio manager init, which returns a void star. So we would have to do const manager of type any opaque. This is the Zig equivalent of void star, and then that would have to be audio manager init, and then audio manager init, which is this definition here. It's namespaced, so it doesn't. This is an error, but this is just pseudocode that I'm showing you. And so then if we were to want to call set audio devices on it, or what is it? Audio restart. If we wanted to call audio restart on it, then I would have to do audio restart, and then I would have to pass in manager. But then audio restart would have also to be defined like this. Function audio restart takes in a I don't know, PTR any opaque. And then if you start having a few of these different resources, then they're all in opaques. And the one time that you switch two parameters around, good luck. Like you're on your own to figure that out. So with opaque, you can essentially give a type to these pointers that you don't know the memory layout of. Like you don't know the memory layout of the thing that they point to. And you can give them a strong type, and you can give them namespace functions. So that allows you from the outside to essentially quote unquote call methods on it. Like I can do engine.call source add, engine.do this, engine.do that. You don't get confused, and you also have the convenience of the language server that autocompletes when you do dot. That's the idea. That is the idea. Okay. Can we commit this? So with this, we have, I don't think we can commit it yet. So with this, we have implemented muting, and it works. We need the activation threshold. Right now, the activation threshold is, actually, where is it, the activation threshold? It's in here, right? Yeah. Whatever. Let's leave it as capture threshold. Volume mute state. This guy also has threshold. Okay, so we have the activation threshold here. Um, I think we need to store this in an atomic property that we keep reading. I need to learn if atomic properties are what I think they are or not. Although we could keep this stored as an atomic variable, that would work. The problem is that how does the UI deal with that then? Because it's gonna spam atomic writes to it, is it not? Huh. Every frame we would need to atomic load, write, and then atomic store. Could be worse, I guess. Okay, so we make it an atomic value. Then, so here's why I am doing it this way. Because now the threshold cannot be just consulted in the network thread and willy-nilly. But instead, what we're going to do is we're going to get this information from the callback. So the audio callback, basically, here's what we're going to do. We're going to compute the power on these samples. Or we do it at the end. Let me think about it for a second. So here we have the caller. We don't have audio, unfortunately. I think here we should have also audio. Hmm. I'm trying to think how to do this in a way that is not too horrible. Okay, let's deep into Objective-C very briefly. And we have the playback callback. But here we have a Awebo compute power, but that doesn't matter. We're good. There we go. Mono, source mono fill. Playback source monofill. Hmm. Hmm. So one thing that I want to do, I think, is also wiring is silence. I want to pass in is silence. And then how does it work? Also, wait, I'm looking at this from the wrong perspective. This is a color playback. Wait a second. We're gonna get to this eventually, but wait. I'm looking at the wrong thing. We're looking at the capture callback. Where's the capture callback? This is it. Oh, the capture push. Oh, that is the one that we care about. Okay. So wait a second. Then in audio, yeah, we're looking at the wrong function. The function we want to look at it's capture push. There we go. Okay, here called by us APIs to let us take audio data from the capture buffer. Perfect. So here we can tell if this frame is silence or or in any case if we want to consider it silence, because what we do is that. So let's see what we do first thing. Capture right slice of some capacity. Okay, first thing that we do is we copy over all the data. Um, but what if we didn't? What if first we computed the power? Hello, Quint. So first we compute the power. Oh, well, what do you know? Uh, hmm, okay. Um, Let me think about it for a second. Here's my problem. My problem is I want to implement the threshold stuff. So I want to see if the power is below the threshold stuff. And if it is below the threshold stuff, I don't want to consider these samples as they are. I want to nuke it and turn it into silence. The problem is we need to keep this count in here. So for capture, there's mute state, there's capture threshold, and there's capture, silence, count. Starts at 10. Yeah. And then in capture push, what we want to do is compute the power. But I want to compute the power before. Yeah, we need to consume this anyway. Okay. Okay. This is good. We compute the power and then we say if power below, and then we need to atomic load the threshold. So audio dot capture threshold dot load. I don't know, unordered. Then we do audio dot capture dot plus equals 1. If else you set it to 0, and then I've already had my one disappointment of the day with Apple APIs, but for now it's mostly chill because I'm refactoring my own code and moving things into better places, like things that I kind of half-assed before. Like I half-assed the implementation of the voice activation threshold and the mute button. I'm now properly wearing them in, but I've already had my one disappointment of the day. So fucking Apple, man, fucking Apple. There we go. So we consume data from the microphone. We compute the power. If the power is below the capture threshold, we increase silence count. If silence count is above 10, just straight up mem set to 0. This could be done better. Probably instead of mem setting to 0, what we would do is a linear interpolation towards 0. So we would kind of want to set the volume, in a sense, increasingly low. Um, but who cares? Okay. This is it. Minus the 75 errors expected according to F32. Find atomic value. Oh yeah, we need to fix the UI. That's for sure. So where's the problem? Oh, there's network. It still has some vestigial code for that. Really? Yeah, this is all vestigial. This is all vestigial, and I think maybe the restart number could be chosen by the audio thread. That would help, I think. Well, if it did, wait, are we? Have I broken now? No, I've not broken. I've not broken anything. Okay, yeah, this stuff can go. It can all go. Like no regrets. No regrets. Yeah, this is fine. Okay, the AV code is broken now. Yeah. Oh, there's audio.m. What? I undid those changes, did I not? Okay, where's this stupid callback? No. Here. Yeah. Um. Okay, AV.zig78. Yeah, now we can't do this anymore. So in threshold now is a unordered load. And then we want to do core.audio.capture. There you go. Are we happy now? One error. But it const. Oh yeah, that's on me. Let's see. Test, test. Volume is low. You know what? Okay, let's do a proper test here. Pause music. Enable audio on YouTube. Turn on the volume. Test. Now. Mute. Mute. I'm muted. No echo. Good. Test. I'm back. Settings. Threshold. Uh, uh, hmm. Prova. Test. Test. Oh. Okay, it's working. It's working. So we have wired that stuff. So we have restored voice activation threshold and the other thing correctly. Now, here's what we need to change. In audio, instead of power, we should have data.silence. No, but this is not. This is not it. This is it. Here we just write down silence. And then in network, when we're about to send, we say if not read.silence, put an event of ourselves speaking. Yeah. Okay, so capture packet ring now has a power problem. Okay. Test. Now the problem is that we still see ourselves blinking, because um, the problem with seeing ourselves blinking is that um, ah, is that on the receiving end we are receiving packets from ourselves, and those packets don't contain anything, but unfortunately we don't know that, but we could know that if we spared just one bit of information in the packet. Microsoft gets tired of Microslop, bans the word in its Discord, and then locks the server after backlash. Really? Oh my god. Microsoft's aggressive AI push on Windows 11 through 2025 brought upon themselves the title of Microslop. That? Only that? Only on Windows 11? I feel that they push it on more than just Windows 11. Holy shit. Unfortunately for the company, it's everywhere on social media, and there isn't a way to stop the spread unless, of course, it's their own Discord server. Right. Windows latest was first to notice that the word Microsoft was actively filtered in the official Microsoft Copilot Discord server. Yeah. Users quickly find workarounds. Of course. Of course. Well, okay, I'm not interested in sure, the word is banned. Slopniadella. Oh man. Oh man. Let's turn on back some music. Anyway. So when we send the packet, we can say whether it contains a silence or not. The problem is that you cannot trust this. Now, we cannot put this information in the packet because we cannot trust clients to be truthful about whether what they have is silence or not. So we need to compute the power. The problem, so here's the problem. The problem is that on the receiving end, the only place where we can compute the power is where we decode the packet. Well, you know what? We could decode it twice. But that seems such a waste to decode the packet twice. But here's what we could do. Basically, when we decode noise, we flip an atomic to true. And, well, we set an atomic to true. And then in the network thread, whenever we receive a packet, we consume that true to play audio. The problem is that though in general everything is out. You know what? The crux of the issue is these fucking magic packets that get sent every 400 milliseconds. I hate them. I wish there was a way of recognizing them. Actually, maybe there is. Wait a second. There are some functions that you can call on packets. Could Opus not let me down? Is this going to be the second time we get let down horribly of the day? Or is Opus going to amaze us? Opus? 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 Opus packet get bandwidth. Gets the number of samples per frame from an Opus packet. Wait, just our Opus packet. This must contain at least 1 byte of data. Sampling rate in hertz. This must be a multiple of 400 or inaccurate results will be returned. Okay. Number of channels. Number of frames. This one's length of a packet. This one doesn't even want length of a packet. Hazel BRR. This might be our boy. So this is not exactly testing for what I'm looking for, but this might be our boy. PCM soft clip. Apply soft clip from blink float. Single within. Okay. Let's test if LBRR is what we want. How's the dev going? Yeah, it's going. It's going. Getting some disappointments out of these things that I'm using, but could be worse. Could be worse. Could definitely be worse. Okay, let's see. In network, let's test this in network. When we are here, we say Um, Awebo, Opus, dot, it has a BRR, read dot data. Read the data, catch. Let's do catch unreachable for now. Actually, why is this an if? Okay, let's see this value printed for a bunch of packets. What? Intcast. Because I would expect those packets to not have LBRR. Blah 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 blah. Blah 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 blah. Perfect. A packet that doesn't have LBRR is a packet that doesn't make noise. So we can go in, we can delete this, but in on the receiving end, we can say this. If packet has a BRR, data. Is it data? Yeah. Catch false. Only if it has LBRR, we turn on the thing. And with this, we have restored peace in the universe, I believe. Test. Beautiful. Beautiful. Pure bliss. You see, now the light doesn't turn on for no reason. Even though we are sending out um, packets. Restart and return missing. Restart and return missing. Thing one. The problem is that we collect a bunch of those. Okay, we need to fix this thing where we keep restarting. I think the way we want to do it is that I think we want to say if the packet doesn't have LBRR, we want to play it right away. How does this work? You know what? For now, that is not a big deal, it seems. So Let's get rid of some vestigial code. I have a bunch of this stuff. Does send still actually happen? I think this guy is vestigial. Actually, the way we can test this is we change the name. Yep, no complaints. You can go. There we go. Got rid of some vestigial code. Yeah, here we're gonna do this. Okay, I think that this is not a bad place where to be. Test, test. It works. Mute works. Also stay silent works. There you go. Try the remote server. Test, 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 test. It's fine. Okay. Okay, so far so good. The only thing is that despite all of this, Dread is still fucked up. So I'll comment out Dread because we did a lot of instrumentation, but Dread is still broken, and I don't know why. So here are a couple of things that I was thinking of doing. One is we could we could um we could try to link against so first of all, I pulled master branch. Maybe pulling master branch is a bad idea. Maybe we should stick to a tagged version, and maybe we should try to link against a version of Opus that it's built from their build system and not built by me. What if I introduced a problem in the way that I'm building it? So I think we have two things to try. Actually, I would try both at once. Like I would just to see if we get any different behavior. So I would immediately, all at once, switch to the tagged version, compile it using their tools, and then link against that and see if anything changes. And at that point, I'll just go and complain to their GitHub because I don't know what the fuck to do at this point. I really do not know what the fuck to do at this point. Um, are we at a committing state? I think we're at a state where we can commit. Hey, Penguin. I think we can commit. Let's look at the diff. So what did we implement? Packet handle BR. Frankly, I could give a type to this thing. Like instead of treating it just as a slice of bytes, I could have given a better type to it, but whatever. Call set mute. Oh, we're gonna need to run CI because we do not. We have to update the audio interface slightly. Not a huge change. We did add one thing. Deleted a bunch of stale code. Yeah, we did all of this. Then next packet begin. Blah blah blah. Okay, this is good. Zig build CI. In the meantime, I'm gonna go to where I know I changed things. So here I added uh, set capture, device mute state. I think this should be capture mute. Oh man, my computer is lagging because of the CI build. You know what? They've been changing these so much. Let's kill it. Set capture mute, set capture mute. And the other place is channel list, right? No, here. Okay, can we do CI now? Also, let me. Never mind. It lags so much. I'll do anything that I want to do. I'll do later. I saw some build errors. That's not good. I saw plenty of build errors. Holy shit. Uh oh. Okay, 3 errors. Expected new type found void. Good catch. Actually, that might have been it. There we go. Okay. I'm gonna go have a lunch. 15 minutes, and then we're gonna make the commit. I'm gonna do the commit, and then after this, yeah, I'm gonna experiment. I'm gonna do one last experiment with Opus. If that makes an improvement, awesome. If it doesn't change anything, then I don't know. I'm gonna, as I said, I'm gonna stop here with Opus. And actually, I don't know what we should try after this. I mean, voice calls are really pretty good shape. We could implement the dynamic jitter buffer compensation, blah blah. We'll see. I'll be right back. Hello, hello. Hmm. I'm back. Okay, what are we doing? We're committing. We're committing. Wait, what are we committing? We're committing crime. Ah, git commit crime. So, was there any to do left? I don't think there was. DTX. Hmm. Did we enable? Um. Did we touch FAQ? We did not touch FAQ. No, Andrew. Hmm. Okay. Hmm. Some improvements. There was a. I think there's a new issue open or something, or a PR. There's a new PR. Cannot pass the bool into cybernetic function on Windows. Ah, yeah, sounds good. We're merging. Approve always, but we're also merging. Okay. So with this, we're good. Okay. So here's what we're doing. Fuck it. We are now going to clone zip opus. Opus. Actually, we don't have it already. So Git pull. Git log. Hmm. Okay. Uh, then we make. Actually, how do you build? How are you supposed to build? Mm, configure make. Development environment. Autoconf automake lib tool. Okay, I'm gonna run this stuff in the meantime. Install the correct libraries. Optional. Once you have compiled the code, there will be Opus demo executable in the top directory. If using autoconf. So autoconf is the one that has. Wait, is it autogen? Oh, it's configure. The fuck am I supposed to use? Why does nothing make sense? Am I supposed to use autogen.h? See the README under DNN. Reddit was developed by a team that Amazon Web Services initially sponsored. Okay. Do we go under DNN then to learn how to enable Dread? See readme.md. Right. What a complete fucking mess, man. Are you supposed to call autogen sh in here? No, there's no autogen sh in here. There's a Mason build file. 15 different build systems, not one that is, is straightforward to use. Not a single one. Oh man. Uh, autogen.sh. So these downloads, actually though, let's not do this. Git status. Git switch. Which tags do they have? Git tag list. Okay, they prefix them with v, so we can do git switch v 1.6.1. A branch is expected got tag, bro. It's, oh my god. So checkout is actually better in this case. I don't know. Okay. Anyway, autogen sh. Let's go. Aborting due to mismatch injection. This could be caused by corrupted download. Yes. Consider the local copy of, yeah. Okay. Hello, Neurosite. And then we're supposed to call them just make? No, we're supposed to call configure. Okay, let's see. Automatic configuration, okay. Floating point support, yes. Fast pulse approximation, yes. Fixed point debugging, no. Hardening, assertion checking. Maybe I do want assertions. How do I turn this stuff on? How do you turn these options on? Are they flagged that you pass to configure? Like this? Oh, there we go. Okay, so configure is the one that has their settings. Okay, so we do enable assertions, enable dread, assertion checking, yes. Make. This guy is compiling one unit at a time. We're getting there though. Okay, so we made some kind of Opus artifact now. We have a bunch of executables that we absolutely do not give a fuck about. Uh, what else did we make? We have sim links. We have object files everywhere. Wait, this does this not make a static library? Actually, wait, yeah. Wait a second. Where do you decide if you're making a static library or a dynamic library? What are we even making? Also, what will making install do? Make install dash p. I don't know. Out. Have we made a directory named out? We have not. Just have a ton of spam. We have no idea what the fuck this thing did. I think we got a bunch of failures. Do we need to create it first? No. Oh. uh, okay, never mind. What is then make install is just run. What the fuck is make install run and make, man? Oh, prefix. Okay, we have. Oh, we did. We got everything. We got the dynamic library. We got the archive. We got it all. Can't complain. Yeah. Okay. Okay. Can't complain. So, how do we do this? We go into our build script, and instead of depending on Opus this way, add object file. Is that what you call? No, link library, but it wants it as a compile. Add include path, add system include path, add system framework path, add library path. I think that's what we want, right? We do add library path. That is not a lazy path though. Shit. I guess we need to copy this stuff over, right? No, 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 no. It can be like this. Opus.add system. Oh, there's system include path. And they're all lazy paths. But we can make them CWD relative. There we go. bad practice, but it works. Also, this is not a system include path. This is just a include path. Yeah. If opus slash out slash include slash opus maybe. Actually, the include path doesn't matter. Let's do lib because we only care about the library path. Yeah, and then opus dot link system library opus needed preferred link mode static. Is this enough? We're linking also opus tools. Why? Oh, also, why am I doing this in the TUI? God damn it. Yeah, and then I don't need to define this either. Okay. Let's see how we do. Um, warning. Unable to open library directory. Not found. File not found. Oh, right. It's because it's CWD relative. What a mess. Hmm. Okay, no failure this time. And we crash. Panic Dread state create fails. Interesting. It's not really This is this is a different problem. Why does dread state create fail? Let's go investigate. I thought I built this motherfucker with dread enabled. So what is the problem? Oh, you know why it didn't fail sooner? I think that this is gonna make it fail sooner, which is what we want. I needed to uncomment the thing that enables dread. Yeah, that's gonna make it fail right away with Opus unimplemented. Okay, so this is an Opus that doesn't have Dread in it, and yet I could swear that we did enable Dread. I guess I need to enable Deep PLC as well. Make clean, make dist clean. Run configure again. And now we get to make everything again. I love this. Oh, Dread compare. So this is doing Dread stuff. Here we did not rebuild. That is a problem. That is a problem. Well, here's how we do it. When this out, don't do this, save. Let's run it just out of curiosity. Let's see what happens now. You might still be using the old stuff. If this doesn't work, I need also to reset the out directory. Option implemented. Hmm. I feel that I might have done some damage. What if we do this and then we do make and make install? Where did you put this stuff? Dot libs. Okay, let's see if that changes anything. This does not. Oh, maybe this should be system library path. No, okay. So we are linking against an opus. Which opus, though, is it? Homebrew Settler Opus 152. Yeah, but who put it there? Okay, I think this is mylib opus. They got placed in user local lib. Yeah, I think. Yeah, okay, we created these a moment ago. Okay, that's fine. So that means that we can run this without the prefix. Make install. We just replace them. Unknown CPU architecture while parsing. How about we do dynamic linking? Will that make you feel better? Library not loaded. Reason. Well, but you son of a bitch. Okay, we might be in business. We are in business. Test. Test. Time to stop the music. Test. Okay. What about now, though? Test. Test. Holy fucking shit. Test. Test. Uh, it's my build. It's my build that is broken. Uh, banana, 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 banana. We keep losing packets. We keep losing. Yeah. You know what? I'm going to mute myself also from the stream. I'm I'm actually relieved. So it means that this is supposed to work. Okay, let's do this. No, not this. Let's do this. I'm gonna comment this horrible, disgusting, um, deplorable thing that I'm doing here, and we'll go back to what we were doing before. Also, I actually don't understand what we're doing with Opus tools. I don't think we need Opus tools, so no Opus tools. Then, oh, Opus tools might be the thing that contains noise removal, maybe, or some other thing. Maybe we'll need it in the future, but we don't use it now. Okay, so now I'm gonna switch back to my own implementation. Sorry, my own build of Opus. And we're gonna hear that it is crap. Test. Uh, uh, Horrible. We fuck it up completely. Okay. Ooh, you know also what I want to try? In jitter buffer. Wait, lowercase ji doesn't find jitter buffer. Is that a new thing? Um, okay, I want to try if I to ask the right amount of stuff from this guy. Okay, we're back to the system provided Opus test. Uh, no. Okay. Even the system provided one has this issue. Kind of weird. Hmm. It's this one. Let's start it again. uh, 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 uh. Yeah. Okay. Um. So this part we figured out. Then, I guess the next thing is to figure out is what else are we doing wrong? So here's one thing that we're not doing right. We don't have the intrinsic optimizations on, and that might be a problem. Actually, there's a chance that maybe what we are experiencing is the result of lag because the neural network is too slow and we lag inside the call. But even then, no, that is, I don't think that is enough. So you know what we need here? Here's what we need. We need make clean, and we need a nice make verbose. Oh my god, there is no verbose. D. Oh man. Yeah, but you know what? It's not really doing anything particularly weird in terms of flags. One thing that we can do, because I'm looking at the flags, it's they don't seem to have anything particularly interesting going on with them. But um but we can look at the config file. The generated config file probably has some stuff in it. The link commands we don't care about. Linking doesn't influence the output. All that much. Let's look at config.h. Get CPU info by ASM method. Get CPU info by C method. Custom modes. Disable DNN debug float. For example. Okay, so that means that now we're going into Opus. We're changing the build script. We're going to have to start trying this stuff out. Config H. So disable debug float. Maybe optional, maybe what? I don't know. Bool default. You know what? I don't even think this should be an option. Fuck it. Uh, okay. Let's leave it like this. Then disable.pro, disable float API, disable update draft, assertions. Yes. Deep PLC, thread hardening. Enable thread, enable deep PLC. Training data we disable because we never fucking use it. Um, we also don't want lost gen. Hardening. Thread, last gen, custom API, OSC. OSC BWE. Also have that one on. Maybe that is what was fucking us up. So in here, our build script, we want to want this. Okay, what else? Enable REST 24, 24-bit internal resolution for fixed point. I don't care, I'm not doing fixed point. Float approximations. Sure. I think we want that. Again, different targets might have different needs. You have a locker. Fuck off, you and a locker. NE10 library is installed on host. DL function. I guess we can hardcode this to true, I think. What is DL FCN? Define to one if you have the elf aux info function. Define one if you have int types. How many of these fucking thing are here? Then how is it that how are you going to do matching in a selection? And I don't remember. It's fine. Malloc hook. No. Make use of ASM ARM ASM optimization. Use generic ASM before inline ASM optimizations. ARM inline EDSP. ARM v6 inline ASM optimizations. ARM Neon inline ASM optimizations. I think we should at least do this. This is resolved already or not? It is. CPU Arch. Or is there something that tells me if there is neon? Is this, is that? Well, we can do this. Neon dot prod intrinsics. Yeah. So this. What's the difference between this and this? May have neon inter. Okay, let's do inter then. You know what? I think that these guys should all be like this. No, we went from have to presume. Wait, we went from have to may to presume. Okay, so now we have presume.prod, okay, which I added. Presume neon inter. Define opus build. We do define opus build. Use runtime CPU capabilities detection. I would say yes. Okay, this is the x86 stuff, which we will want to do at some point, I guess. File report, package name, package string, package URL, version, SDC headers. C99 variable size arrays. Yes. Okay, I think we are good. Okay, now it's time to try a build with our fork of Opus. Do we need anything else in here? I think we're fine. Let's see. Let's see if we build and how it goes now. That was way too fast. Fast. Uh. 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 Okay. Right. There we go. Okay. Yeah. Now. Now we're in business. I did not downscale. Let's see what happened. Okay, we're missing the arm stuff. Oh, let's go. So this is more stuff that needs to change in here. I mean, we knew that there were a bunch of things of this kind that we were missing and that are architecture specific. And yeah, guess what? It's time. I'm gonna do the work for ARM, and then we're gonna need to do it for x86 64. So, what can I say? Let's go. So, so Celt has some of that. Is it all Celt? I mean, some of it is Celt. Okay, let's start with Celt then. So these are the normal files, and then we can do um, conditional concatenation, I think. I hope. If target result, CPU, architecture. Actually, what is dot features? Add feature is enabled. Oh, so like we could do something like this. That's how you do it, probably. Let's do the shitty version for now. If it's Arch 64, okay, if it's Arch 64, what we're missing? So we're missing arm CPU.h. Oh, wait, this is us compiling Silk looking for Celt ARM CPU. Okay. Okay, that is even. Jesus. Okay. Let's comment it out for a moment. So go in Silk. Okay, is this gonna make it better? One error, 104 errors. Any difference? Not really. Celt arm CPU.h. File not found because this guy expects. Oh well, wait a second. Okay, because I guess in pitch analysis FLP dot C, you're trying to find this. Okay, one step at a time. Celt arm CPU.h. Okay, these guys want it. These guys want it. Does it exist? It does. Okay. God damn it. That is the fucking problem. Okay. Oh, oh, we're adding. Oh my god, we're doing the same everywhere. Okay, made progress. We are missing a lot of a lot of stuff. Undefined symbol, silk noise, shape quantizer, short precision, neon. Oh no, we're missing the ones that are like architecture specific. Okay, cool. So this is it. Okay, this is it. Let's go. Where do we start from? Silk, Selt. Start with Selt. So these two guys seem promising. Oh, that's how we do it. Okay. Cycle time, const 20, yeah, blah, 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 and type of. Ah. Hmm. How do you solve this? I always forget. Mm-hmm. Is there really no way to make this conditional? That is so annoying. Fuck it. Okay, you won. 13 errors. Okay. We solved a lot. Holy shit. Silk LPC. What are we doing here? We're doing Celt. We might have solved the Celt, I guess, in our case, maybe. Okay, let's go to Silk. Okay. All right, these are all. Although we could do this. Actually, maybe we should do it also up here. Mainfix.h. Mainfix.h sounds suspicious. Is this a function with a main? This one's mainfix? Fuck is mainfix? Silk/fixed. Oh, because it's fixed point. Right. Why do we even care about this? Okay, good. We have eaten some unknown symbols. Some more remain. Parse weights. Opus select arch. celt/CPU support implemented by dump modes. No, implemented by arm CPU.c celt/arm. Oh, everybody has their own. Okay. Okay. Um, we probably want to do the same also for Silk. So one symbol solved. Nine remaining. Parse weights. Parse weights. Mm-mm-mm-mm. Parcel PC net weights. But why do we need this? DNN/parcel PC net weights. I think this is opposite self. I'm gonna bring this with me. So we're missing parse weights. Reference by opus decoder. Decoder load model. Okay, so it's in here. In DNN, parse LPC net weights. Hmm. 6 errors. We still haven't solved opus select arch. Oh shit. Oh, because opus select arch is needed at the top level. Actually, maybe I was wrong adding it down below. Where did I add it? In Celt? No. Did I add it in Silk? I did add it though. Where did I add it? Did I dream adding it? Did I dream adding it? Oh, I did that by doing the include thing. Wait, did I change that by doing an include? No, you need to add CPU.c. The fuck? But I don't think this is gonna solve it. I think we're gonna stay at 6 errors. No, we're down to 5. Okay, that is cool. Computer linear.prod. bbw enetdata.c in DNN. Okay. bbwe netdata.c. So it's not this DNN. It's the other DNN. Where's the other DNN? Wait, no, actually I'm confused. No, 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 no. This is definitely that DNN. They typo it? bbwe net data. bbwe net data.c. How is this not found? This file is definitely in here, is it not? Hmm. Is this a version mismatch problem? This might be a version mismatch problem. Yeah, this one does not have the BBW stuff. Ah, okay. So we need to solve this actually once and for all. Uh, that fucking C source file is generated. That fucking source file is generated, man. Wait, does that mean that he's in the other DNN? Oh yeah, it's in the other. Oh man. Ooh, okay, it's in the other. Okay. It's not in here. It's in the PLC stuff. Oh man. Okay. I felt like I was going insane. Don't say this, dude. Don't say this. Don't lie to me. I know it's in here. Oh, I think I know. It's in here, but it's okay. It's in the root. Okay. Okay. Come on. Next linking error. I know you're not done. There we go. Now we have compute linear dot prod. DNN slash arm. DNN slash arm. So I guess that means that if model PLC, there we go. Come on. What else are you going to throw at me? 3 errors. Oh, spaghetti. Wait a minute. Motherfucker. I thought we fixed this. And net.o wants this. Yeah, this actually should be in here. If thread and arch, then dnn slash arm. But it's a header file. No, this defines. This has the forward declaration, and it has a function call. Wait, where the fuck is this thing defined? Oh no. Oh no. Where is this thing supposed to be? Who's calling into this? It's nnet.c. I think we kind of need nnet.c. I find it difficult to think that we should not be including nnet.c. That being said, we could try, but I don't think it's the right direction. Yeah, we lost some definitions that we need. So no, we definitely want a net.c. Is this compute linear dot prod? Where is this thing? Where even is this thing? I think our G is there a way of saying G to ignore the git ignore? Yeah, no ignore. This has to be somewhere. It's nowhere. How is this nowhere? How does this even compile? Compute linear dot prod, compute linear neon. Presume dot prod. Oh, I think I get it. This is supposed to be. Is this supposed to be the intrinsic that we don't have? Google, hello? So, no. Why am I looking at YAML files? Why is this an endless collection of YAML files? Oh my god. Um, I think I'm fucking something up in here that I don't understand. Define if defined L if define computer linear. Okay, so we're defining computer linear kind of wrong somehow. If defined opus arm presume dot prod. Yeah, but this doesn't really change much because then where is computer linear neon defined? Do we have that one either? At least? armdnn map.c. I think it's this file maybe that is doing some turbo weird macro shit to produce those definitions. Let's try. What the fuck just happened? What was that jump? So is this thing generated by that weird macro? I'll if this is it, I'll take a look. No, it's not. We're still back to missing computer.prods. So it's not this file doing it. DNN compute linear implementation opus arc mask +1 may have neon, may have dot prod. It's a macro may have dot prod that comes from God knows where. But I think it's this. Oh my god, what is going on? No, dynamic library, no dynamic libraries, static linking only. Oh, look at these guys that we are not including. I think it's them. But why did they not show up? Define rtcd arch.prod. that's that's the chunk. That's the chunk of the function name that we were missing. It was smuggled in this define, I think. Um Holy shit. I don't think we were supposed to add all of them though. I don't think we're supposed to include all of them. We'll see. I think they're gonna fight over those definitions. No, but they did have guards around them. Oh, we linked. That's where our function name was. Man, somebody was asking me yesterday, how do you learn how to um package Zig projects? Dude, it's insane. Anyway, let's try this. Uh 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 no, it's still fucked up. Banana, banana, banana. Uh 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 it's a little bit less fucked up, but it is still fucked up. Why do we compile it worse? You know what it is? I think it's UB. At this point, I can only think that it is UB. By the way, Phantom, if you're still around, to to test this, by the way, I'm testing my build of Opus against one that I use with their build system, which I am linking dynamically. So I'm using it. How can I say? I'm A/B testing against that. So um, I'm making use of it, but I want a static build test through my build system. Okay, test. Uh uh so you see how good this is. Banana. Banana. While my version is fucked up. Uh 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 Mine is broken. Why? Why is there not broken? Oh no, wait a second. Mine is not released fast. Wait a second. Release fast. Uh uh oh, that was it. We did it. We did it. It works. It works. Uh uh Finally. Success. Finally, success. Uh I'm gonna mute myself so you can enjoy the packet recovery. Sorry, yeah, you're right. I forgot to unmute myself. Thank you. So I was saying, yeah, this thing it truly is fucking incredible. Man, it took a while to get here though. Holy shit. So the fact that we were lagging, okay, so now I can understand what was happening. We could have yeah, it's so we could have detected this also in the past. The problem probably was that what was causing some glitching in the audio is that we were this competition was taking too long, and um we were essentially wasting too much time um computing Dread, and that was causing glitching because we were too far behind, and we were writing late, and probably that was also causing some of the secondary issues, although some were because of our usage of the library. So this is now as it should be. Like everything is as it should be, and it finally works. How's the CPU usage? I don't know. We can take a look. I don't know if you maybe you want something more precise than HTOP, I guess. No. Well, here's what I can tell you though, Neurosite. We are computing, I'm decoding the Opus packet in the audio thread. So we're essentially doing it in real time. Yeah. The reason why I'm doing this is because I'm essentially waiting at the very last minute for everything. Like, this is the current design of the jitter buffer. The current design of the jitter buffer is that the coding happens in the audio thread on demand. So basically, the jitter buffer stops packets as they come in, and then the audio thread has the duty of, when it needs more data, has the duty of, well, selecting the appropriate packet, which is either the next packet if we do have it, and if we don't have it, it will do either forward error correction, the older forward error correction if there's only one hole. So like if the current packet is missing but the next one is available, we do forward error correction. Otherwise, we do dread with Opus. Whew. Now now what is it that we have gained from this from this whole thing? What is our payoff now? Well, our payoff now is that we get to do it all over again for x86 because now yeah, we get to do it all over again for x86. Technically, we could also disable Dread, for other platforms, but I mean that's gonna be a thing that we worry about once the time comes. So now we need to do this. We do we do GUI. The local cache doesn't matter. We do dash d target x86. Actually, let's do Arch 64 Linux. Does this work? And I guess we can try Arch 64 Windows if we really have to. No. So, no, we exploded. nnet.prod C is being compiled without .prod enabled. Arch 64. Hello? Is what? Armfeature.prod is false. The compiler doesn't do .prod. So you're talking about some other thing some definition that we don't control. But why would the compiler not do .prod? It's the same compiler. What is the difference? Target probably. Yeah, well, oh. Let's try this because that is a good point. Does R64 include .prod? I don't fucking know. But here's the thing. I'm not checking for it. I'm checking. Oh, what you're saying is I'm checking for this, which is actually a simplistic check. I should do a more thorough check, which I'm not doing. And then when we are cross targeting, we target a baseline CPU that doesn't have it. That is a good point. Maybe it's time that we Maybe it's time that we make this real. I mean, we did say that our payoff was that we got to do it all over again. So I have no idea where we get these guys from. How are you supposed to do features? You know who has some of these? So Mac Engine actually has Hex Ops. They actually have Opus. And it might be that they even do a better job than us. Actually, they definitely do a better job than us. Let's see. I'm just gonna steal some. Oh, there we go. Target x86 feature set has target CPU features. Has .ssc 2 4. Okay. Oh, they do this with addc macro. Okay, we're doing this with the config header. So you do std. This might not be up to date though. Okay. The target dot arch64 dot feature set has. Oh, there we go. Set target dot result dot cpu dot feature. Oh, we even get auto completion. Let's go. There we go. Has neon. Has dot prod. Delightful. That is actually pretty delightful. So here we can do has neon. Hello. Thank you, Dylan, for the raid. Hello, everybody. Everybody, anti-raid. What? Welcome. So you caught me at a good time, actually. So I am in the process of packaging Opus, not the AI model, not the thing from what's it called? Anthropic. But Opus, the codec, which introduced insane packet loss recovery. So give me a second. So I'm going to just change these lines and I'm going to turn on the application and you're going to be able to see it in action. So and then I'm going to continue my work. But I will do a demo in a second. So has neon has dot prod. Thank you very much. Then may have neon ENTR. Oh no. Intrinsics. I don't know. This do has neon. Has neon. Has dot prod. Has neon. I don't know. Let's assume that this is good enough for now. Okay, I'm gonna run it. I'm gonna run the application. So here's what I'm gonna do. I'm running the application. Actually, you know what? Let me do the full demo. So I'm gonna run the application and I'm gonna go to Opus and I'm going to disable everything. I'm going to disable forward error correction. I'm going to disable all kinds of packet loss concealment. So we're not going to enable anything. And then you're going to hear what happens when packets are lost. So running the application, none of the packet recovery stuff is enabled. Test. You hear the echo. I'm going to turn it on also for YouTube. So actually, I'm going to mute myself. Not right now, I'm muted in the application, but I'm going to mute myself from OBS. So you're going to only hear me through the application, and then we're going to start dropping packets. And then I'll show you what happens when we turn on all the packet recovery stuff. So hello, you're hearing me through the application. Debug. And now I'm going to start clicking in, drop 3 packets at a time. So, that's easy. Let's try with speech. Banana, 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 banana. Can you understand what I'm saying? Hello? Can you guys hear me? How do you hear me? Hello, 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 hello. So not great. Pretty robotic, huh? Yeah. Let's turn this on. I'm going to try again. Hello? You're hearing me through the application. Hello, guys. Can you hear me? We're dropping a lot of packets. Like, this would be a very, very horrible connection. And yet, I think you can still hear me. It's kind of insane. It is kind of insane. There is some work though to get here. You have to do, man, to set it up. Oof, it does take some effort. But also, I would say that this is essentially state of the art. We're close to state of the art when it comes to packet loss. Because there's a couple features that I still need to implement in my jitter buffer. I have a simple jitter buffer. Probably serious projects have a more complicated, more serious jitter buffer, but not thanks to me, but thanks to the people that make Opus. This new Opus stuff, this is called Opus Dread, and it's based on neural networks. And their packet recovery, well, they call it packet loss concealment. Their packet loss concealment is stellar. And you would not believe how little data is sent over the wire. Like a Opus packet is something like 140 kilobytes every 20 milliseconds. So every 20 milliseconds, we send out a UDP packet that contains 140 bytes of data plus, I don't know, like, let's say 20 bytes of header that I add. And that's it. That's what you were hearing. Of course, this is a local test, and I'm dropping packets artificially. But I was doing also tests online with a real server, and this is like insanely good. So this is state of the art, and I think we can boast something that most of other applications don't have, because most other applications use WebRTC, and WebRTC does not have support for Dread yet. They still need to standardize it, so they cannot, since it's a standard, they first need to standardize stuff before companies start adopting the new thing, etc. So it's going to take a while for them to get there. Also, I picked at a bit of the code in WebRTC, like just a couple functions. Holy shit, that thing is a disaster. Like just a couple of lines, man. I don't know. It's C++, so I mean, it is what it is. But holy cow. Okay, so let me send out a message, and then I'm gonna get myself some tea, and then and then we're gonna fine tune all the intrinsics that we like, all the feature detection that we have in the Opus package, Opus package. Okay. Yeah, this is amazing. Really amazing. Like, this is this is so good that basically, you know how there used to be a time where like people maybe born in, I don't know, the 80s or something. Hey Fathom, thank you, Fathom. Thank you for the resub. Thank you very much. So you remember when you're old enough that you remember the sound of a floppy disk getting read by a computer, or the sound of a CD tray going in, going out, the CD spinning up, those sounds, and then your generations don't even know those sounds anymore. Um, Guys, you can start forgetting about the robotic voice sound. That's gonna be a sound of the past. It's like it's gone. Even the robotic sound, like you heard it right when in my first test, the super robotic thing, that's gone. The Opus people have killed that sound. You should give it a try with some background music. Music often kills these things. Yeah, you're right. I think I haven't read it in detail, but I think the way it works is that in Opus, you have two codecs running at the same time, and you have Silk that does voice and Celt that does non-voice. And what happens is that yeah, I think that well, these packet concealment stuff right here is only voice. So I think the voice might be preserved and the music might die. But I mean, yeah, that is a good test. How are we gonna do it? Free copyright free music. Okay. Yeah. Okay, I can get music through my microphone. So how did it sound? Did I got my music decently well enough through the microphone? It sounded it did sound fine, right? Oh man, the US robotics modem dial up. Oh yeah. You know what? I still remember also when that fucking thing was dealing the wrong number because you got a DLR installed. And so like you could hear that it was phoning the wrong number. Like you could shut it off on time. Oh man. Okay. I'm gonna mute myself and well, you guys tell me how it goes. Yeah, sorry. Okay, so how did it go? Sorry, I forgot that I was muted. I saw the neurosite said, "Holy shit!" So I guess it went well. It's hard for me to tell. Sorry, because the thing is very noisy and I'm hearing everywhere. So in any case, well, this is it. Okay, so this is very good. Give me a sec. I'll I'll go get myself some tea, and then we get to build this stuff. Also for XCD664. Ah man, let me just send a message. So I'm sharing in the Italian Zig group, um, kinda the the puzzle that we encountered. Like, where is this freaking function defined? I'll get something to drink. I'll be right back. Okay. Ah, tea is coming. Here's what we do now. We build this for actually this is what we were doing before the raid, right? We're trying to build it for Linux. Problem is for Linux it was pooping itself because we were targeting baseline CPU and some stuff was not working. So there we go. And net.prod.c is being compiled without .prod enabled. So we still have this problem, but we might not have fixed all the things in here. Have we? Basically, this, I think we only want to add if we have .prod. So if it's if it's Arch64, we want these guys, and then I think we want this. Take this out. Then if has neon, we do the neon one. And then the same with .prod. Like this. I also don't know why I'm doing a release save. That doesn't help, but anyway. I think we succeeded now. Actually, might need to do the same below. Do we have the same thing somewhere else? Yeah. Hmm. Do we pass this around or do we copy paste this? Uh, I think we pass this around. There we go. Also, you know what? Let's remove has. Once it's in CPU features, it's obvious. There we go. Target not accessible outside function scope. Okay. I should not have done release safe. I'm gonna remove it after this. But yeah, success. Okay, so this works. Arch 64 Windows. Can we build for Windows? Oh, so an error. Configure to use ARM ASM, but no CPU detection method available for your platform. Reconfigure with disable RTCD or send patches. Uh, right. So because we were looking at this, we're looking at our config. Well, so we're looking at our config.h. CPU info by ASM, CPU info by C. I guess for Windows, well, on Windows we don't link libc, so we should have. Oh, I see what's going on. So basically, in our case, on macOS we always have link libc, Wait, so does that mean that if we try to do Linux muscle, it's not gonna work? No, it is gonna work because it's another libc, but we always link libc in our case. So why is Linux fine and Windows not fine? CPU info by ASM. How do we feature check this? But we were still doing Arch. This is just x86. C feature check. CPU info by ASM. And how do you check this? How does it check CPU info by ASM? C feature check. Maybe this is it. It's configure. No inline admin for the platform. Please send patches. There we go. ARM may have EDSP. May have media. Test X dollar opus. How does this work? Checking for Apple style tools. Pre-proc if else. If not def Apple. ARM assembly requires Perl. What? What? Oh my god. I just have no idea how this stuff is supposed to work. Oh, there we go. Here's how it works. If enable RTCD, yes, and test RTCD support if and then. Huh. Get CPU ID by ASM? No. How to get x86 CPU info? Inline assembly. C method. Configure to use ARM ASM, but no CPU detection method available for your platform. What does that mean? I guess we should take a look at ARM CPU. Salt ARM CPU.c. Okay, so if and if else. If and if. If and if. If and if. Else. Elif. Okay, so we have to look at the outer stuff. Oh, the outermost, man, this thing is incomprehensible. By the way, if just we got these people to use Zig and stop using C, and they stop having to deal with this endless amount of bullshit, holy shit, we would have done like a giant favor to the universe. So if define MSVC version, oh, I think I see what the problem is. MSVC has no Opus inline ASM support for ARM, but it does let you emit instruction via their assemble hex code. All of these instructions should be essentially no ops. Define Win32 lean and mean. Win32 extra lean. What? Underscore underscore accept get exception code equals exception illegal instruction. Ignore exception. Elif. Otherwise, if it's Linux. Otherwise, if it's Apple. Otherwise, if have elf auxiliary info. Have elf auxiliary info. Otherwise, OpenBSD. Configure to use ARM ASM, but no CPU detection method available for your platform. Okay. So we were saying the Linux is fine. The problem is Windows. What if we do Windows MSVC? That's a problem because we don't have MSVC. Um, what if we kind of lie and we set MSVC if we're on Windows? MSVC there. Let's see what happens. So this is in Celt. Or you know what? We just disable it on Windows. I don't know. There you go. How do you like it now? No, but we disabled RTCD. Oh, wait a second. Is this a thing where we need to set it to null? Six errors. Translation failure. Uh-oh. These are translation failures of our own headers. Oh no. That's bad. C import failed. Okay, so our Windows adventure ends here. x86 64 Linux. Let's go. Okay, that succeeds, but it's not good because there's all the other intrinsics that we don't have. We just don't have. We need to do these guys. Run bit exactness checks between optimized implementations. Compiler supports if binary requires. Compiler supports binary requires. What does that mean? May have presume. I don't know what the presume stuff does. I think I'm going to omit the presume stuff and only keep the may have. Out of curiosity, what happens if we do this for our native target? So test, test, test. Yeah. The presume stuff doesn't seem to be. I don't get it. I'll get rid of it. Okay. AVX2, SSC, SSC2, SSC2, 4 underscore 1. Maybe it's going to be like this. I don't know. Oh, come on, ZLS. Give me something good. Fine. Oh, why doesn't ZLS want to give me any help? There's no x86-64. Oh, god damn it. Why is there an Arch 64 though? Um, OS. There we go. Oh, it's x86. Okay, fine. AVX2. We need to do AVX2, SSC, SSC2, SSC 4.1. Okay. And with this, we have all of these intrinsics. Anything else? Presume may have. ARM inline neon. Okay, so the next thing, I think I want to take a look at these guys. Actually, it's not even ESR64. I guess it's ARM. Let's try this. Oh, is EDSP a feature that we need to check for? No. What's EDSP? Miss Celt float to int 16 implementation X core Celt pitch X core dual inner prod check within implementation. Ooh. In libcelt and in libopus. So libcelt is looking for this. Is it because of these guys? Or was it something else? It was something else. When did we pull this in? When did we pull those in? I'm confused. When did we pull those in? Definitely none of these guys. Is it because of taking out the presume? Presume Arch 64 Neon Inter. Presume Neon Inter and Arch 64 Neon Inter. Oh. First of all. Yeah, okay, it's these guys. Okay. But what if I comment these two out? So the Arch 64 one we probably want to keep because it's different than the other one. But are those also needed? Those are also needed. Interesting. So we do need the presumes, not just the may have. So presume AVX, presume. So they may have a presume counterpart. Again, what's the difference? Who knows? Okay, let's see how this goes. Okay. Actually, let me try it just in case. Test. Uh, ah. Test. Okay. Um. Okay. Then here's what we need to do. You know what? I think this is fine for now. Fine. Okay, let's continue our adventure. Out of curiosity, did they somehow help the Windows case? Maybe we got our own problems. Okay. Is Linux still working? Okay, Linux seems to be still going strong. Then okay. x86 for Linux. Do we link libc? Yes. Okay. 8 errors. Okay. That's nice. We're just missing. We are just missing some stuff. Although you know what, I think that the baseline CPU doesn't have AVX, so we need to turn on AVX. I think it's. Can we just do dash M CPU? I guess we'll see. Anyway, so here's how I think we can do it. Everywhere we had the ARM version here. Actually, let's do is ARM. What do we need to use here? X86. Wait, did I have the same file twice? Oh my god. Okay. And then here, okay. Although this should contain only map. This is gonna be CPU features dot SSC. Oh, if it's just SSC, then nothing we can do. Because it's gonna be SSC2. Okay. For one and AVX. Okay. Whew. Do you need to duplicate all the flags? No, I could collect them. Yeah, but I do, but you do need to. What I would like to do is I would like to be able to add and remove um things conditionally from a list of files, but it's proving tedious because of the type system. I think I knew how to do it in the past. I forgot, but I think there's a way of making it work, but I just can't figure it out anymore. So I'm copy pasting a bunch. Yeah, the flags could be collected somewhere. That is true. And programming is such an interesting, such an exciting job. Huh. Okay. um, so we did do the SSC stuff and the x86 stuff here, but we need Celt. Thankfully, Celt is a lot less. And include x86. There's these guys as well. Holy shit. Okay, so if it's x86, what do we want? Thankfully, the file names will suggest to us what we're supposed to do with them. So this says here, this says here. I think I did a very good job with ARM. Celt ARM CPU, ARM Celt map. And then these two guys go into Neon. There's the NE10, which might be optional. We're definitely missing at least ARM Celt map. I don't know, I'm gonna leave NE10 in there and see what happens. Okay, in here, then we have these two guys. Everything else is specific. So here we have the SSC one. SSC2. SSC41. AVX2. Okay. Let's see if the okay. Let's see how we were doing. Oh, silk needs also. Yep, we're gonna need these guys. Okay. Oof. Okay, it's like this. So here we want features SSC for 1, and then we want neon. I mean AVX2. So there we go. Okay, let's see how we're doing now. The Stealth Armor Pitch SSC. Uh, it is work. Can I do plus AVX too? Actually, no, it has to be GNU. But the plus stuff doesn't work. Mm, is there really no way to specify CPU features without adding extra flags to the build script? Can you pass them in like this? No. Can you do plus m dash m CPU like this? No. Okay, let's see what the Zig build menu has for us. Invalid option D OSCE BWE D float approx. What makes you say that that's an invalid option? Oh, I think the fork flag is not kicking in. That's fine. Oh, DCPU. There we go. Target CPU features. Like this. Wait, how do you use the CPU? The CPU string target CPU features to add or subtract. Um. Oh. Oh. Wait. How the fuck do I know? Generic Pentium. There's V1, V2. Okay, so we do X. Well, basically, it's CPU models slash packages. So you don't turn on individual features, but you do. You go by models, and I think x86 V4. These are like the quote unquote subsequent versions or baseline versions, where V4 is the most recent baseline version. I think V4 has all the SSCs. I don't know if it has AVX. We can test this. We can add a um we can add an assertion in the build script to see if V4 has that. How do you supposed to know the model? Yeah, well, yeah, I don't think it's perfect. I think the problem is that if you toggle in on and off, yeah, for example, this one has AVX2 in it. The problem is that if you toggle on and off individual features, some of them have weird relationships. For example, some are probably mutually exclusive. Sometimes one implies another. So if you come up with your own succinct list of things that you toggle on and off, you're probably going to come up with impossible combinations easily, while these um, things guarantee you that you have sound combinations. That's what I suspect it's happening. Okay, we're missing Silk inner product FLP AVX2. Okay. In any case, that did have AVX2 in it, so success. So we're missing some Silk AVX2 stuff. It's the Silk FLP stuff. Oh, because under float. Guess what's in there? Did they actually add all these files? Oh, some are C, some are not C. There you go. Floating point, if it's x86. And we have AVX. Oh, this is interesting. We need to do it like this. Okay. We went from a pretty shitty um uh Opus package to a state of the art Opus package, I would say, for all your code base. Okay, so success. So I think we're good. Um, I think we're good. Whew. So enable architecture specific optimizations. Test uh, target opus the 1.6.1. Only x86-64. Our architectures might require more work. Whew. Do. That is not needed anymore. That is not needed anymore. That is not needed anymore. So here we're good. Zone file. We remove Opus tools. We need to fix also the TUI. So copy this. Remove this. Cbuild CI. Oh no. What have I done now? NE10 DSP. Hmm. Hmm. Uh-oh. Uh-oh. The fuck is the N? Okay, you know what? The NE10 stuff goes. Um, why was I not seeing this earlier? Why was I in here? And I did not see this. Okay. Like, what the fuck? Okay. Well, so our adventure is not done yet. We're getting there, but it's not done yet. So is it? I think that okay. These just enable like whatever it's missing. DNN compute activation implementation. DNN compute combination with the implementation compute linear dot prod. Oh my fucking god, we're back at the dot prod shit. No, dude, please, not the dot prod stuff. What have I done to deserve this? We'd added the WWE stuff and PLC model. Where's the PLC stuff? DPLC, there we go. DPLC. Use DPLC for Silk. So both places we do it right. We don't try to create opus anywhere else. We don't touch it. Don't do weird things. Um, I think I'm messing up some of these things somehow. Are we returning false for is arm? Okay, is arm? Are we arm? Because the answer might be that we are not arm. We're not arm. Okay, this is the answer. So Arch 64 is not ARM, but that is not a problem. Unless we go in here. Okay. That's probably the change that broke everything. Okay. 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 There we go. Everything works out. So next, um, we commit. So what do we have in here? We have Opus stuff. Man, look, this diff is so. There was such a weird diff. Like this diff. Oh man. It's fine. Wait, why are we reverting this? Oh no, we should not be reverting this. That's Flow saving all the files when I don't want it to save all the files. We have been silently reverting good changes. Oh no. We need that change from Neurosite. Power is coming. Nice. We do anything else in here? Oh really? Oh man, this feels so good. Whew, what an adventure. Okay, we have state of the art packet loss concealment. That is crazy. You know also what state of the art packet loss concealment gives you? The ability to be stupid aggressive with your jitter buffer. Because, I mean, yeah, you can technically, I mean, you can definitely completely run out of packets if you're too aggressive. But even if you're a little bit aggressive and you occasionally lose one, two, or apparently five packets in a row, who cares? As long as you have another packet. Like basically your goal is to have at least one packet one future packet to play, because you can pick any future packet essentially to play, and it's gonna be fine. So funny. Um, so um, what do we do next? Man, I don't even know what life is. Not having to worry about packaging Opus. Like, what do people do when they are not packaging Opus or integrating it in a jitter buffer? What do you do for fun? I don't even remember anymore. Man, you know what? I'm gonna listen to some music, and they go back to writing Objective C. No, no, no. Oh no. Um, you know what? I think we need. I think we need the mini IO backend, mini audio backend at this point. Like at this point, calls are essentially usable. The only thing that's missing is an audio backend, a non macOS audio backend. So that's all. That's all we need, and then we can do calls with people. And calls are going to be pretty good, unless modulo some bugs on in our implementation. As long as you don't try to touch your audio devices, like the enabled audio device, as long as you leave that being, then the call is going to be good. Oh man. Oh man. Ugh. Hmm. I'm gonna go get tea. I deserve it. Ah, okay. Let's see how we're doing with CI. Oh man, this has been running for 7 minutes. How long does it take? 8 minutes to run normally. Oh Jesus, this took 20 minutes. These builds are wild. Okay. Um I think that we're getting to a point where we might start thinking about screen share. There is so much more stuff that needs to happen. That it doesn't happen, like basic stuff. I don't know. Maybe turning on also screen share could be cool. Although, you know what? I think this is a good stopping point where we stop here and we consolidate what we have before, because video is going to be another giant rabbit hole. So, before we get into that shit, let's stop and make what we have good. For example, you can mute yourself, but we're not sending the mute notification anywhere, and people cannot see that you're muted. Do you have a Linux out yet? No. So Andrew has done some work in the old audio backend, which I completely removed, and we have now a new audio backend. There's this PR from um, Antlang 7, who is implementing a multi-platform backend using mini audio temporarily. Like the idea is that we don't want, this is not where we're stopping. But while we don't have anything better, these would allow other platforms to play along. So that's what I said in the PR. I said, as long as the contributor is fine with the idea that this code is eventually going to be removed, that is the goal. But in the meantime, if they want to uh, do this, then they'll get us to a uh, it will get us basically to being able to try it out on other platforms, and then we'll see. So I actually really don't know what to do. I mean, it's usable as it is. No, okay, let's do the microphone stuff, I guess. Let's do the microphone stuff, right? So idea is that when we mute ourselves, um, we send out a notification. Oh, also, you know what I want to do? I want to edit my fish prompt slightly because on that bird, I want this. I wish there was a Unicode comma thing that we could use for a as a tongue. No, Wikipedia, you're not good. Can I have a dark version of these, please, bro? For my eyes. No. Okay. No. Hmm. No. That's kinda it. That's kinda it, but not quite. That was really good though. We got real close with that one. No. It needs to be something that stays kind of in the middle. No. Maybe this. No, never mind. This doesn't even show up in my font. Mm, nope. Nope. Yeah, this one could be good. But it's probably too small. Doesn't even show up. Do we somehow break this? No. What's a tilde going to look like? Honestly, the tilde is good enough. That might be even a little bit too much. Okay. But okay. Good enough. Okay. We're saying new notification. So go to the protocol, go to the client, call join, call leave, I guess in the middle we can have call update. And status is gonna be Awebo. Oh, wait, that's already where we are. Caller dot caller dot status. Although, no, that doesn't work. This is more like muted, bool, deafened, deaf, deafened, deafened, like this. You update on whether you're muted or deafened. What else? What other status? What other different status might you have? How does the intent to share is gonna work? I don't know. We're gonna worry once we get there. Okay. Could use it this. Oh yeah. Holy shit. They could, huh? Good point. Good point. I think I already got bitten by these ones. We probably want to copy a little bit more. I think we want to copy up to that point. Actually, no, I got bitten because I called the wrong one. I didn't get bitten by the other one, but yeah. No, never mind. That part we don't care. Or rather, we um oh, you know what? This doesn't need an origin even because we are not gonna reply. So or else log dot debug client. or not in a call, which can happen as long as it doesn't happen too often. Then it's a bug probably, but it can happen. Origin client request a client rate limit. Okay. Then what do we want to do? We want to get the caller information. So where do we have callers in here? There's channels, but I don't think we're keeping callers. Remove UDP, TCP broadcast. That's all we have in state. Whew, okay. Handler routine. Kernel 32. Set console handler. Oh, I think I added this delightful stuff. Well, okay, so here's what we can do. We can go up here and we can take a look at what we do when we join a call. State client's voice index. There we go. And then we send media connection details. So we have a voice index. Yeah, there we go. Clients that express an intent to be in a voice call. Not all clients listed here have a UDP address yet. Okay. I think we don't store this information anywhere. We have the concept on the receiving end. So, like, I think in the client, or actually even in core, we have callers update, which is a callers update. Oh, callers update does contain a caller and a action. Okay, so the server does generate a callers update. Which does contain a caller. Oh, but we just make up the caller like this. I see, we don't track shit. We do not track shit. So basically, entries in a voice call. Hey there, Teufel. How's it going? We succeeded. Complete success. Flawless, actually, success. I had to do a lot of work, but we now build Opus with all the architecture specific accelerations. and it works amazingly well. So it just works amazingly well. Period. Okay, so we need essentially this. We need the room. And then U64 found what? Oh, ID and nonce. No. So that's not how it works. So that's not how it works. Voice index. Hmm. So there's a channel ID in there. Does this guy have a channel ID? Oh yeah. Okay, so this guy does have a channel ID. Okay, so it was right. Okay, there we go. That gives us the room, and then okay, what do we have in it? It's a hash map. Essentially it's a set of client pointers that are in there. But I think it's time we give them values, and the value needs to be a Awebo caller. Actually, not a full Awebo caller. There's a lot of redundancy. Um, I think it's more like this. It's more like state. So that way we can isolate a subset of these that we use. When it's like screen sharing, and then audio is on audio state. I don't know about the screen sharing, but for now, also, you guys come here. What am I doing? Yeah, by default, it's not screen sharing. Audio state is none. This stuff is redundant in our case, so that's why we do only color.state. There you go. And you know what? This is cute. This is really cute, but we don't do it for now. We do this. Capture muted. Capture muted server. Playback muted. Playback muted server. There you go. I don't know if I want to have playback muted server though. This one is misleading. I'm not doing it. Okay. So the screen sharing thing might be bullshit. You know what? Let's remove it. It's bullshit for now. So this is how we have it. Then this struct is part of protocol, of course. Then in here, we save state. Perfect. Wait, why am I mean, oh no, I'm in a loop. Okay. So we grab the room and we say, actually, yeah, we grab the room and then we say const color equals room dot get pointer of client. There we go. Okay, so we have the color, the pointer, then we do color dot um, capture muted equals cmd dot muted color dot playback muted equals cmd dot deafened. Actually, these are better off called uh, like this. Deafened. Muted server deafened. I think we're missing an E. You spell it like this, right? Yeah. Okay, we just update these things. And that is essentially it. Well, no, we need to send out a colors update now. Now that we have updated this, time for a colors update. So now, hmm, well, we want to read this information first. So we do. Oh no, but you know what? Even the send portion needs to be done by holding a lock. So never mind. How do you send out a TCP message? That is for the client. How do you fan out? TCP broadcast. Let's go. ID is udp.id. You cannot send a colors update until this user has a UDP. There we go. Maybe client colors a pen. Where are we here? With Delta. Oh, compute Delta. Maybe we shouldn't fuck this up. Maybe this one should be done precisely. But we have clients head. Wait, where do we get ourselves clients? Oh, it's passed in. So client voice index. No, we got it by pointer. Call join request should actually give us the initial state. Actually, it should be like this. Okay. So now we have this information. Now we need to display it. So we're passing it around, we're storing it, we're replaying it back, we're updating it. We're not always getting it 100% right. I think I left a couple of default things that probably require more thought, but well, let's say that the information is now available to us now in channel list. When we render all the people participating in a call, we need to also show this for callers, caller, blah blah blah, label, pending, color, label no FMT, display name. No, now it's label FMT, and it's gonna be something like this. Why is it M? User is called M. Why? Okay, for now, let's just do this. Okay, join. Holy shit, we instant crashed. Oh, well, I mean, that's fair. The poor server has no idea of the new protocol. We need to restart it. Okay. Uh, we're muted, but we're not really displaying it. So here's the question. Are we sending a notification to the server? I don't think we are. So go to core, call set mute. Okay, so how do we send messages to the network? Uh, let's find a less clever way of sending a message to the network like this. So host, what does the active call have? Active call has host ID. Okay, so that's where we got the host. Grab the host, call update. Muted equals Um, yeah, maybe I should turn those booleans in the server back into more expressive enums, but for now it's fine, I guess. I set the other one false for now because we don't set it. Hmm. Okay, let's see. What happened? Scene marker C and then everything exited. Did the server die somehow? No. Server is fine. It's the reply that we got that we didn't expect. Did we make any change before restarting the server? Um, let's restart the server again. The fact that we had to build it kind of tells me that maybe that is the problem. Also, this guy is not doing well. Okay, let's try again. Nope. Okay, so scene marker C. So the server is fine. The client dies. I think it's on the receiving end. Um, to be fair, I didn't add coding network for this, did I? I wonder why I didn't get a. No, wait a second. We get a colors update, right? We should just be getting a colors update. Okay, wait a second. Server run. Oh, this is the reply marker. This is R. Okay. Colors update is C. So we do see these. How are we? Why are we crashing trying to set this? Actually, not even crashing, we're returning. Oh, you know what's happening? I bet you that we are trying to update a color that doesn't exist. No, you know what? That doesn't explain why is the network that would leave. Um. Oh, wait a second. That's the problem. in server, when I create the colors update, this is an update, not a leave notification. There we go. Obviously. Um, that's my fault, copy pasting too much. There we go. Muted. Unmuted. Muted. Unmuted. Ta-da! We have muted unmuted. Amazing. Amazing functionality. I should have run CI before pushing, but we just touched business logic. So if it builds for us, it should build for everybody. Yeah. Okay. This is good. So I think I'm gonna stop here. This has been a success. This was another day of work, but we got a huge success. We got Opus Dread to work fully, and we're now kind of at a point where we don't want to push forward with new features. Instead, we want to polish what we have. We want to take what we do have and we want to make it solid. It's not a bad place to be in. So with this, yeah, we're now essentially okay. So essentially, we're waiting on other audio backends, and we're waiting on um, more hardening of client interactions. And at that point, we can have an online instance of Awebo if we want, like publicly accessible even. Two things needed: audio backends for non-Mac, so that others can, participate to voice calls. And we do need more. We do need resilience from user interactions, because I don't think we have a ton of that going on. But that's it. That is it. Hello, X2. Sorry, X2, you're arriving at the end if this is you saying hello. Otherwise, well, otherwise nothing. That's it. That's it for me. Man, Dread is amazing. How much is needed to get Wasapi up to macOS state? But man, I hope that you can get Wasapi to a better state than what's macOS. I'm not happy with the state of macOS, but I honestly don't have an answer. I have no idea. We do have the old Wasapi code from Johnny. I don't know. So for now, I think that this is gonna be the most likely thing to get us to a working audio state for other platforms. This integrates mini audio with our current semantics, and I don't know. We'll see how far Antlac gets. In the meantime, if Andrew decides to push with Linux, then we're gonna have Linux. Otherwise, on my end, man, I did it. Holy shit, I finally did it. We have everything. We have good playback. We have a decent jitter buffer. We have the latest and greatest that Opus has to offer. So what else do you want? I don't know. In any case, thank you all for hanging out, and I see who I should raid, and then I'm gonna call it a day. You know what? I think I will send you all to Ethernet cable. There's Ethernet cable alive. Anybody else doing? Okay, out of curiosity, who has a Zig tag? Is anybody with a Zig tag? It's only Ethernet cable. Well, in any case, that better. Go say hi and enjoy some more Zig. Hey, Antlak. Looking forward to your backend. If you get it working, man, this is gonna be so cool. See you all.